So let us view the slideshow. This lab in our unit is about bridges. A bridge is a structure that carries a road or a path or a railroad or a canal over something like a river, a ravine, a road, another railroad, or an obstacle. So it's basically a pathway over an obstacle. There are many types of bridges. Arch bridges are one of the oldest types of bridges that we have. Originally, they were built of stone or brick. Today, of course, we use concrete, steel. The load on a arch bridge is carried outward, so the weight is pressed outward, and the curve of the arch is supported to the ends. And the support carries the load and keeps the ends of the bridge from spreading out and falling apart. And then the center of an arch bridge is the keystone. A beam bridge is the simplest type of bridge. It needs to be stiff to resist twisting and turning under a load. Its horizontal beams are supported by two piers at the end. And under the load, the top surface of this bridge is pushed down or compressed, while the bottom surface is stretched and placed under tension. And the farther apart these supports are, then the weaker the bridge. You have a truss bridge. The main element of this type of bridge are these structures that are called trusses, these interconnected triangles to give structure. It transforms the load from a single area to a much wider area. These bridges are made of wood and iron, which resists tension better than stone. And finally, the suspension bridge. It's light and strong. Suspension bridge can span further distances. So if you have one crossing a bay or a big river, it's typically a suspension bridge because these cables help transfer a lot of the load and they are attached to an anchor system. The cables are able to withstand tension, but they offer no resistance to the compression. And the bridge is suspended from cables that are attached to tall towers at the end, as you can see. The word span is the distance between two ends of an arch of the bridge. So there's a span here, a span. This bridge has many spans as it goes down. If we look at this diagram of the bridge, we have something called abutments or pillars. Those are the end points of the bridge holding it and supporting it. And in a cable bridge and a suspension bridge, you have anchorages, which are these devices that hold the cables to them. When looking at the forces that act on the bridge that we talked about, you have tension. Okay, that's the force that acts to expand and lengthen what is acting on it. So it's going to push out this way. You have compression, which acts to shorten the bridge and it is acting on. So the compression force is coming down like this, pushing it inward. You have buckling, which is the force that compression overcomes the ability to handle the compression. So the bridge starts to buckle if there's too much compression. And snapping is when the tension overcomes the ability to handle the tension and the bridge would break apart and snap. Okay. We are now going to move to your CAMI lab report. So go ahead in Schoology and open up the CAMI document. You will be typing in the CAMI document in all blue ink. You can copy and paste from the Google questions these statements. So these will be the questions from now on in the edpuzzle, and you will just copy them to your lab report and answer true. Make sure you copy them and change them to blue ink in CAMI, just like you see on the screen. So the problem for our lab that we're going to be looking at is that we want to know, does the design of our bridge affect how much weight it holds? So based on how your group designs your bridge, will it hold more weight? To do this experiment, we will be using pennies, and you will be designing a bridge solely out of pennies. You will have 100 pennies in which to build your bridge. Each group will get multiple sets of pennies so that they can build multiple bridges at the same time and everyone is working. Once you have a penny bridge completed, you will call me over and first you will photograph the bridge and then you will call me over and I will put a Lego man first on top of the bridge. If it holds the Lego man, you are successful. And then we will put metal washers stacked on top of your bridge to see how much weight it can hold. And you will record your data. Our hypothesis is if we build our bridge as drawn, then it will hold the most weight. So you're going to draw a sketch of your bridge in the box provided once you are in groups, and that will be the first design that you kind of construct out of your pennies. It doesn't have to be a super drawing, but it just has to show that you know what the bridge will look like. Your independent variable is the design. That's what we'll be changing. Each time you will redesign your bridge and make 3 different bridge designs for this lab. The amount of weight it holds will be the dependent variable. That's when it's going to change based on the group's design. And some of the things that remain constant in this lab would be that we're all using pennies, the coin. We all have 100 pennies for each bridge. The span of our bridge, meaning the distance that it has to have empty, is 3 centimeters. The height going up of your bridge has to be 3 centimeters, and the platform that you are building on will be the same as well. And that concludes writing on your CAMI lab report. You do not have to turn anything in. Simply click submit after this edpuzzle to get your grade on this assignment and X out of your CAMI lab report. Again, make sure you've copied all these items onto CAMI and you've done that in blue ink.